Hi, welcome back to this AOP. In this video, we are going to be working on component form of a vector, being able to express a vector in terms of I and j, and performing vector addition, subtraction, and scalar multiplication with those vectors that we have. So, first, this component form is a way of writing a vector in a simpler form to be able to add and subtract them and stuff. It just means that the starting point is the origin, so 0, 0. And then the ending point is, let's say the origin is here. This is going to be vector m, okay? And the ending point is here. So we're going to write, when it's in component form, how far it has traveled x direction and how far it has traveled in the y direction to get to this point. Okay, this would be the vector here. It wouldn't be a vector of just like a line like this or like this, or a line here and a line here. The vector is this straight line here. Okay, but it's got a coordinates here, and that's sort of how you write it in that component form. Now, with this, that being said, if theta is the angle in here, we know that cosine theta equals, adjacent over hypotenuse, and sine theta is opposite over hypotenuse. So, if we are given, say, not points in rectangular form, if they're given as the vector, the length, and the angle, then we can convert them into rectangular points to be able to more easily write that. So all we have to do is multiply both sides by m, or this vector length. Then we have the x value. And then if we do the same over here, we can get the y value. So it's easiest to write vectors when you're given rectangular coordinates, but if you're given the vector coordinates and you want to write it in component form, well, you can just use these to convert that to rectangular coordinates, and you'll be set to go. So it says write these vectors in component form, so we're going to get this equation here. And in order to write it in component form, first we have to understand where the vector is. So it has a starting point at 10, 13, and it's a line that travels down, so it's going to be kind of going down in this direction to 0.15. So to get the component form, we simply subtract the starting point from the ending point of each the x and the y coordinates. So it's going to be 1 minus 10 for the x, 13 minus 5 minus 13 for the y coordinate. Okay, and then vectors in component form are typically written with these pointy brackets. Okay, so that's going to be -9 and -8 for that vector. Okay, and now you've written it in component form. It's as simple as that. So we can do that with this starting point and ending point. So it's going to be it's going to have -5 minus 3 and 10 minus 7. Okay, so it's a point that starts up in the first quadrant of 3, 7, and then travels down and up, or left and up, to point -5, 10 in the second quadrant. So it's going to make sense that since it travels left, x is going to be negative, but since it travels up, y is going to be positive. Okay, so we have -8 and 3. Okay, and it's as simple as that. Now in this last one, it's not quite as simple, but still pretty simple. So remember how we found this identity here to be able to get the x and the y of this line right here? Well, m and this v here are the same. Okay, and the theta, well, that's going to equal 60. So we have 15 cosine that theta of 60 equals x. Okay, and then we have 15 sine 60 equals y. Okay, so this, we know that cosine of 60 equals 1/2. So this is going to become 15 over 2. And then we know that sine of 60 is the square root of 3 over 2. So this is 15 times the square root of 3 over 2. And that is actually the x and y coordinate for component form of this vector. So we could just write it 15, 2, and 15 times the square root 3 over 2.